So today is the March 7th, 2023. This is the bi-weekly Kepler community meeting. So we have on the agenda to update the progress we have made during the last 2 weeks. And also we asked Ken to have a presentation on the new model training pipeline. So let's just go through the progress we had so far. So let me share my screen first. So the progress we have made during the last 2 weeks, including the operator. So thanks for Peru and Kai, we have the community operators as the operator hub. So if you are running OpenShift and potentially Kubernetes, you can go to the operator hub to install Kepler, and that is a good experience for you. So maybe next time we will. There was actually a quick demo. If you go through the YouTube video playlist, there's a demo on the operator. So this was made by Peru. And if you follow through the demo, you should be able to get ideas of what this operator can do and how to use this on OpenShift. The second progress is the standalone Kepler. So as the project started, we mostly look at how Kepler can be used on Kubernetes. So it runs as a daemon set, it collects information from the system, and export is Prometheus endpoints, and eventually be presented on Prometheus dashboard. The standalone Kepler on the other side does not require any containerized workloads. It can run on your operating system without Kubernetes. So this is the use case for workloads that's running as processes or virtual machines and still want to have the capabilities to capture the energy consumption on the Kepler level. So the exporter function is still there. So if you scrape the endpoints, the Kepler endpoint, you should still be able to see the metrics. But instead of the container metrics, Kepler dash container dash whatever metrics follows, you only see Kepler dash process metrics. So the energy is as the granularity of individual processes, and also the CPU, the ePPF counters on that level as well. So this is what we have. Let me see. We also have some progresses by the IBM team on the platforms supports. Let me see. Do you have the people here? So Sam, do you mind just share what you have made on the new platforms?
You mean 390?
Yes.
Okay, so actually we just beginning with some internal discussion and investigation on the 390 there, and we try to try something on eBPF. Currently Kepler is focused on 86, and 86 is with some BPF pointer there, but it's different on 390. So we just start with investigation from here.
All right. So Jason, do you have anything to share with us?
Hello, can you hear me?
Yeah, I can hear you.
Okay. No, I actually had a sync with Yuanyi already. So what he's sharing is what we are doing now.
Okay, that's good. So I think one of the things we have discussed before in some of the meetings, some meetings ago, is that we currently using the REPL for x86. But on many occasions, one is that a repo itself has some restrictions. You may not get repos as frequent as you like. The other thing is on other platforms, that's a on different platforms, that's a non-x86. You may not have the same CPU level readings. So we are thinking about using IPMI, BMC, on the mainframes case, HMC. It's using the whole machine level power readings for as energy source. So that means we have to move away from the integrated power reading that's read from the CPU to the external power reading from the IPMI or just HMC. So this is something, if people already have experience on it or have ideas on it, then we can just start breakthrough and
But just to mention that the power metrics that we collect from the CPI is the same that IPMI collects, but IPMI just use a different interface. So in theory, if the host has the sensor, we should be able to read that, so we don't have the RAPL metric, but we will have the total node.
Right. So that is very, so it's already started. So we are moving away from the RAPL and we can use the ACPI. But I think the last time we checked is the ACPI is very IBM specific. Not every vendor using the parameter. So IPMI, the other side, is relatively popular on many of the server setup.
But the IPMI is just a library to access this method. It's the same source. So you can access it using IPMI, or you can just read the file. And in Kepler, what we are doing is reading the file, and IPMI should return the same thing. So it's just a matter of which library you're using.
All right. So we can just think about that the use case and how can we support it. But I do not want to overload the Kepler functions with different libraries. So my thinking is
so if you need to use IPMI, it means if we want to read metrics from another host, but to read metrics from the same host that Kepler is running, I think it's just duplicate code. We don't really need IPMI. We were actually thinking about IPMI in the beginning, but there was a better way to read the metric through the file.
So the file reading, I mean, that definitely works on certain setups, but not on everyone. Because the servers we have on many environments do not have a parameter. So IPMI is the only way. So if we want to use it, so this is my thinking. If you want to read IPMI, that's one way we can just have. One way that we have is IPMI reading in the Kepler code. The other way is we push IPMI exporter, sit somewhere else, and we read the model, read the parameters, read the power from that exporter. So it's going to be decoupled.
I'm saying that it should have the file. Maybe change the path. So just need to check if it has IPMI. If it's responding IPMI, power metrics, IPMI is reading the files somewhere, and if the file path changes, we just need to fix that. We don't really need to install IPMI in it and have all the library for that. Just fix the file.
Okay. I think if you access IPMI, you have to have some certain credentials. So if we expect the credentials to be available, it's going to be very sensitive.
Yes, Huang Min. So no matter for external RCs to get power consumption from external cells. So what I'm worried about is security, like a credential, maybe token or something. As same I found in recently I'm investigating with benchmark, and I read something about our C group part code and also Kubernetes part code. So somehow currently Kepler get Kubernetes RC some Kubernetes exporter at node level for some memory usage, etc. So what I'm curious about this design, because physically, if we have a VM or something as Kubernetes node there, right? Kubernetes is running on the node, and Kepler also running on the same node. So the Kubernetes actually exports the power or say something like memory usage in a Prometheus endpoint as exporter there, right? It actually reading some files or CPU usage, memory usage, etc. But by as Kepler, we open a web request to the Kubernetes matrix there as a network IO open. So in this case, we open two IO, for one from Kubernetes to provide the data, and one Kepler side to read the data. So why not we just read the data from Kepler to the file or memory, etc. on the Kubernetes node? So I don't get the point of current implementation.
So the use case of Kubernetes, instead of going through so there's two issues. The design goal is to minimize the Kepler's resource consumption at the node level as well as the cluster level. So we, in case of you have a large clusters, tens of thousands of nodes, and if you are issuing the request to the API server, that's going to be a huge load on the API. So we decided to use the Kubernetes to isolate the traffic at the node level. So it doesn't matter how many nodes you have in the cluster, Kepler can only exercise at the node level. So that's one of the things. The other thing is we have different type of models. So on the bare metal, we're using the ratio-based and eBPF hardware counter-based and ratio-based model. So when you run it on the virtual machines, you do not have eBPF hardware counters. You do not have a REPL. So you use the C group model. And on C group, you have V1 and V2. So on environments we do not support, you can use the Kubernetes model. The Kubernetes should have the most consistent interface, but it also has the least available features. So that is the last result for all the models we can support. So that's probably one of the many design reasons we support. We have different level for data collection from hardware, from the OS, from the C group, from Kubernetes. That is to support different deployment models.
Sam, can you also repeat your question? I didn't understand very well. Yeah.
Me?
Yes.
Okay. So recently, I tried to add some benchmark testing for C group and Kubernetes, right? But I noticed that first we do some self-implementation in Kepler, and second some self-implementation just go from network level, from Kepler, open a network thread to request data on remote some endpoint belongs to the same Kubernetes cluster. So I just wondering, as the Kubernetes cluster gets those data by some, Kubernetes node there, which means there's some API or some package already implementation reading the C group file, and from the C group file convert them into Prometheus way format and export it. So I'm wondering that the question is, if we don't want to go or run as current way, is there any possible for Kepler to consume any, or say to invoke any Kubernetes code there and further get the data from C group files directly? As I opened one of the discussions there, I found some C group implementation in Golang, and seems that package do the similar things with our implementation. So I don't mind to figure out something related with Kubernetes, Kubernetes implementation for the node, for some engine exporter there. But I just wondering why we need to go through an external network IO open to get the data. So we can somehow logically maybe use file IO to get the C group data loaded in Kepler and analyze them, right?
Yeah, this is a good point. So there are, I think, many comments here. So the first one, definitely, if we see a library, external library that we can reuse, it's better. Currently, we have a problem that we support we only collect metrics from C group version 1, version 2. I did a local extension in my code for version 1, but it doesn't work perfectly. That's why I didn't submit a PR. But we need to collect metrics from C group version 1 as well, isn't it? So but there are some libraries that support. I tried to do some investigation for that, but I didn't pursue too much about that. So what the Kubernetes code, it actually has C advisor inside. So they actually use C advisor to collect C group metrics, the metrics for the containers. They have so we maybe can investigate how they are using that and try to use in a similar way. It's as far as I try to look a little bit, but as you mentioned, they have different implementation of in Kubernetes, probably different projects, different extension. Wasn't very easy to see how they were using C advisor there. But if we can also use C advisor library to access these metrics, it will be much better. So we can just reuse, and also it has version, and then we also saved from anything extension, support that these libraries already support, and it would be great. So this might be some extension that we could do. This is great. The other thing, to access Kubernetes directly, we have like many things here. One is introduce too much load to the kubelet. We don't want to create overhead. And the other thing is kubelet reads there is some delay also to read the metrics. And if we are indirectly reading things from kubelet, it means we are maybe creating a synchronization problem of metrics collection, and that's why it's better to just read it directly. But definitely to use a library, we can improve our code and all the C group implementation that we have. That's my comment.
Yeah, so Marcelo, that is a very good comment from you. The other time I read the code from the run C and Squire, that the node level, the container level information was exported through HTTP protocol. So if that's a different process running somewhere. So if you want to get the container level metrics, activities, C group information, you have to go through that HTTP interface. On the HTTP server side, I don't know if the code are exportable, meaning that can we call them directly? This is question mark. If they're not exported externally, then we are not able to use them call them in our library. So this has to be investigated. On the other side, the Kubernetes, the load on the Kubernetes at the moment, I do not see that is a huge concern to me. If you include the Kubernetes support as the binary or as the library, that's great, but it does also introduce the dependencies. If any of the things in Kubernetes changes, then we have to change as well, and that also creates the support metrics issue. So we can keep the conversation, but at the moment, I think we probably can cover one of these releases for the optimization and external library dependency resolution. So let's just finish the functionality in the first two, this release and the next one, and then we can do all this refactoring and the external dependency investigation.
Yeah, great. So I'm going to take a look if there are any Kubernetes implementation offline and further update in current discussion with the group.
Okay. So Hannah, are you ready to share your screen?
Yeah, let me try.
Okay, let me just stop my sharing.
Oh, okay. I'm sorry. Is
Yeah,
it
you're
already
ready.
there?
You're ready.
Okay. Yeah. I think I have about 20 minutes, but I don't think I will spend all of that. But okay. What I'm going to talk about is about the project. One repository in our organization is called Kepler Model Server, and in this repos we have like 5 main contributor over there, and it's still work in progress. And these presentations, I would like to have like a roadmap for the Kepler model servers. What should we do with it, and help wanted. Okay, I'm trying to change the slide, but okay. Yeah, the motivations of this repository is like we would like to have our model servers that provide their power models to estimate their power consumptions on some system that we have no power measurement. And by training from some other system else that we have the power measurements, we have got everything. And we would like to apply the model that we train to that system that have similar architectures or something like that. Currently in the Kepler model server is just redecided, and now it's contained like previously we had the online trainings and the model server API decided in, but I just put another components called profilings for the profile servers to support server clustering stuff and do some isolation stuff. Okay, I'll explain that later. Anyway, the Kepler model server now is contain 3 components: profile, train, and the servers. And the whole design is look like this. We're supposed to have some contributor to contribute on the data to train the model. And we are going to have the Kepler model server to like make a profile, training the models, and provide that to the servers so that the user or the consumer who have no power measurement and wants to estimate the powers can ask for the model and apply that model from our Kepler estimator. Okay, before I continue to the next step, is there any questions for the current one? Okay, maybe it's too early. For the first step, like I'm sorry, how we like profile or how we like generate the model. Are we supposed like to have some contributor running some benchmark? And we got some values for the benchmark we call it performance values. For example, this can be like iterations per second or read-write abilities of that system. And we will get the data. And based on that one, we supposed to do some clusterings, the input, so that we cluster any server into numbers of the groups. and we create profile for each group. Here are, for simplicity, I separate into 3 groups, that is 0s, 1, 2. And we will create the clustering model to cluster any incoming servers. And then we use that data for training the initial model for each type. To train the model, we call it like a training pipeline. For each type of the servers, we create multiples alternatives of the models. Is trained by a different way. For example, some may use the scikit-learn XGBoosting, or some may use like the Keras, as will like be online training later, so the errors may be changed. At the API servers, it will choose the base one for each type, returning to the consumers to apply the model for that one. I guess it's a little bit confusing, but any questions here?
How you select the model?
Okay. First of all, like it depends on the similarities of the servers. Like if possible, we would like to have the consumer to run the performance values, and then we can like use this clustering model to determine what type of the server is, and then inside that one is will choose the minimums errors at the base one. Yeah, but of course it can have the order filtering stuff, like you can specify the for example the trainers that you want, but the default one is will select the base perform.
So can you, for example, I think the baseline case will be the CPU version, isn't it? So we say this is the CPU model that it has, and then it returns a model. Can it be like that? Because I know that some VMs doesn't expose the CPU version, but it also, some of them expose. I understand that the ones that it doesn't expose, we need to get some general power model and whatever it can comes. But the ones that we should have the exactly CPU model, it should return the model that it's trained for this specific model.
Yeah, it could be like a specific one, or it could be like a categorized that one. I mean, it's not determined yet that how we should like group the servers, because if we are going to have all combinations or possibilities of the server, it will be very big. That is why I do the profiling and clustering any server to a groups of the similarity. And currently it's how to say determine the group by the performance values. But of course, if we can access the CPU versions, is maybe another conditions to determine the group as well.
Yeah. Yeah. Okay.
Sorry, I maybe get lost or confused. So, yeah. So maybe I'm sorry first, but we have Kepler model server, and it including some progress as profile training, and it has a server there.
Yeah, let's start this from here. Okay, this is the whole flow of where the data come in and what is the model come out. And because we have many kinds of the servers, we would like to have the model server that provide the models for any platform, like any possible platform. So we will have a lot of we expect a lot of input from the contributors, but we cannot have the model for each combinations or each possibility. So that is why we need the profilings to some clusterings and profile for each group. And based on that profile, we do the training model for each group of that one. And the server inside here actually is the API servers that will be just the the front end that the users ask for the model, and then it select the best one that has been trained and return to the users.
So
So
Right.
so that part is some like operator or some user interaction API groups, right?
It's another module of Kepler. So Kepler has 3 modules actually. We have the main one that you are working. There is another one that is the estimator and the model server. So the main one that we have internal power model that it's called ratio. That's only using only one metric to divide the power across the process across the containers. And this ratio is just simple: 10% of CPU utilization, then 10% of the energy goes to this process. However, CPU utilization, that is what's actually we have CPU instructions, is not necessarily show all the utilization of the CPU. For example, it's using cache, it's using other metrics. So then we have
So the things make me confused is from this current architecture module. So we inside the Kepler module server we have another server, or the training actually a part, I would say the profile, the training and some interaction API endpoint, all of them are in the same component named Kepler module server. Our Kepler module server actually 2 parts. So first is AI part related part as profile and training, and the second is another server just running inside the Kepler module server.
Yeah. Let's say this one is like is this the repositories, or is this a project inside their organizations? But what is deployed into their cluster is just only this part and the Kepler, which I can show quickly at the end. Like this is the what deployed in the Kepler, and this is what we usually call is Kepler model server in the operator. Is this only this part? And this is their domain.
Oh, okay.
Yeah.
Okay, more clear for now.
Okay. Yeah, and this is the first step that I expect that the way that we generate the initial model that we can provide at the API servers. I don't think, or maybe we can talk later. Okay. And this is the second phase. This is the first phase that I would like to have first, but if haven't done yet, I need a lot of the help to make this work. And also we need a lot of the discussions that are on the design as well. I will do that later.
So yeah, I just have this question that all of this profile, if we really need that, because in the beginning, I was thinking about the model server, was that I was mentioning to you. We have different CPU architectures, different CPU models, and people can train, provide data for us to train a model. For example, an ARM architecture, a power architecture, whatever, and also different CPU versions.
Yes.
And then also different machine that has GPU, machine that doesn't have GPU, the power consumption of the node is different. So we have some system configuration, and then the list of this metadata of the data collected from the node. We create a power model. So that's when someone is running a similar machine, it provides metadata and download the model.
Yeah, that is the discussion that we can make. In that case, it will be like we may have no need for the clusterings and profilings. We can have a single profile for a single data input data, right? And just find a similarity to that each of the metadatas, which profile is the most matched one. That is one way as well, that we don't need to group the servers. But the reasons that I'm trying to first generalize it by grouping the servers is because I'm thinking about like, okay, we can have the set of the groups. We have initial model, and instead of creating the new, the new pipeline, the all of the profile, because it will be a very big chunk of the input and metadata to share. Like you have to find a similarity of like for example, if you have a 100 data set, you have to find 100 maybe too small, but anyway, we can like generalize this by that. Like we can have a 100 of the profiles and comparing the metadata, but it will be also a big thing as well. But what I'm thinking is, okay, let's starting from something that more generalized, because we don't have that much big amount of the input of the data. And also after we do the profile on the initial state, we can apply the scattering stuff, and we can make it like a better model. Instead of trained by just a single data set, we can like train by a similar servers, but with a different not necessarily the workload. One, we can have the wide workload and clusters from what we have, and we can improve the model type that we have from the similar data set. But I'm not sure which one is better. First
Yeah, I
we
think
need to collect the
we need to
data, and then
investigate, also
Yeah.
investigate that, because mixing data set might disturb actually the power model.
Mhm.
You know,
possible. Yeah.
I think this is Tamar. It's an interesting, really interesting discussion. One way you can look at it, Marcelo, as clustering obviously is the most general idea here. And one way to cluster is just by default using the architecture and break according to different architectures, right? So that's one way to cluster. May not be the best way. So there could be subcategories under an architecture. For example, if you have a larger memory size, or what is the configuration, that may affect the power model. So you can think about it as subcategories, or you can think about it as super categories, what Peng was saying, I think, which is maybe two architectures are actually similar and can be grouped together. So that's like a super category.
right.
And
I
Yeah,
think
but
it
the
makes
other
sense.
idea that I thought where you're going in is the clustering for the workloads, because potentially different workloads may have different power models. So clustering based on whether it's CPU intensive or whether it's memory intensive, and then you can get maybe more accuracy. That's another thought there.
yeah, we may include that as well. It's very also interesting as well. But yeah, it's take a little bit on design. Thank you. Yeah, let Mark sit on. Okay, and okay, let me continue. This is the second phase after we get the profile. We expected to have the other wide workload, and then we trying to improve the model, and then we expected to get some better models, and when the consumer asks for, we can get we can return the better model. This is like the second phase. And this is the demo that I pre-recording for like the first phase, that how I prepared the tool to collect the data on the first phase. So let me run the recording. This tool is already available on the Kepler model server repositories under the source and profile. You can like starting from like deploying the Kepler. First, the monitoring system must be deployed. Like that is the Prometheus, because we are going to use the results from the Prometheus query. So this is like to starting from checking that the Prometheus is running there. And then we have to clone T repositories. That is the one is the Kepler. And the second one is the model servers. And the third one is the new repository that create is called Kepler model database, because because we don't have the server to collect to keep the data. So we now use the GitHub repository for the DB. And note that is we have to fork this repository, Sustainable Computing Kepler Model Server DB, to the local, because we are going to push our our collected data to this repository and push the PR to the main one. Okay, and after we clone, everything is there. So the next step is to deploy the Kepler with Prometheus or service monitors to make sure that the metric is available there. So let me skip for a while. This is the way we deploy the Keplers with the Prometheus. You can see that the service monitor is also deploying here. And because I run in the Kai server, so I have to patch a little bit to the pull request. And after the Kepler is available, I make some script to like do the port forwarding of the Prometheus to export the metrics to this port. And then I just check whether the Keplers is available yet. So the first one is like mistaken because it's too long. This one is showing the models, the Keplers is already exported some values for the node package. So the next step is like, we have to remove that a little bit. You have to prepare the Python environment as well to run the script. That is what we require is a Prometheus client because we have to query the Prometheus from the Pythons. I create a different environment for that with the mini condas and install the Prometheus client, but you can deploy it in your environment from the requirement.txt in which already instructed in that one as well. And after every environment is prepared, what you need to run is only the, I'm sorry. Okay, wait a minute. Yeah, you just run the script by script and run. And then after you run this line, everything will set up. I mean, like it will check the prerequisite here. It will deploy the CPU operators, deploy the benchmark for collecting the performance value and those stuff. So after for a while, it will run the call mark. This is just only one benchmark that I have right now, but we need to add the other benchmark as well. After we run this comma, I think the next thing that I'm going to show is inside the repository. You can see that what is the benchmark is. This is how I define the benchmark. This is the call mark. And inside here, we run like multiple variations of the workload, like from the 4 thread to X, 16 and 32, and run it for 3 times. This is the current definitions of the benchmark. And then you just wait about 10 minutes for the benchmark to run all of 3 repetitions. And okay, I will skip until this one. Okay, after the benchmark is done, it will like automatically record, save everything, save the results, create the commit, and delete and cleaning everything. And after that, what you need to do is only script and okay, wait a minute. After everything is done, there will be a new file in the Kepler model DB and query response. With the corresponding hash values. And what you need to run again is the script push. This one is to push the new collected data into your local repositories that you fork from the main one. And then you can see that here is will push here. You just need to create a PR from that new commit from the new bunch to the main one. And then inside here, there will be just only 2 files added. One is the result of the benchmark. That is the iterations per second. And this is the performance values that I'm saying. So based on this one, we can make a categories of the servers. And yeah, and another thing is this the response.json. Is this the results from the Prometheus query? And this will record every like stat from the Kepler's exported. And based on this one, we can make the profile and also train the model from this input. So any questions? I think it's end of the demo, but we continue to the presentation.
Sorry, Pen. But is actually the program running your demo? Because from what I see on my side, I thought you are still just showing the structure of the repository. But is your video, does your video has the demo? You guys everything started?
Which one?
So from my side, I can only see the 2 consoles you opened, but I did not see any progress.
Oh,
But if you already have the recording, maybe you can just watch the recording after the meeting.
yes. Oh, wait a minute. You mean like you cannot see the screen?
No, I cannot see the progress. I can only see the GitHub repo and the 2 console, but I cannot see any progress.
We can see your screen, but previously, maybe you play the demo, but the demo is not played at maybe
Oh.
our screen, you know.
But we
Okay.
can let's
Okay.
just attach the video to the meeting after
Oh,
after
I
we're done.
see. Yeah, can you see it right now? I mean, like,
Yeah, we can watch it now.
okay, you can. Okay, yeah, you should tell me first. But yeah.
No, I thought you had just
Uh,
introduced the structure.
Oh
Maybe you
no,
can
no.
just-
Yeah, I'm playing the screen, but I see the Zoom require me to change the screen to
Okay.
share. I'm sorry, but okay, what should I continue? Basically, okay, I will share these video layers, but it will show that how we can collect the data to and push it to the GitHub repo. I can quickly go through. The first thing is like deploy the Keplers, and then you just prepare the environment, everything. And what you need to do is just going into the Kepler model server, run the, wait a minute, I will go into the highlight one. Yeah, the highlight one is that you just run the, wait a minute. This will be around here. Yeah, the highlight one is here. Yes, just run the script dot, wait a minute. Yeah, this one, just script dot run, and then it will like check all the prerequisites and deploy the CPU operators, deploy the benchmark. You just need to wait the benchmark to be done. And after the benchmark is done, it's right here, I think. Yeah, it's after the benchmark is done, it will like do everything for you, including creating the commit. And after that, you just can check that there is a new folder in the query response that the new data that you collected. And what you need to run again is the script and push. And then after you push it, it will update in your fork here on the right hand side. And then you just compare and create a PR from this one. Yeah. And that is all to
Is there
configure.
any guideline to create the PR, like the metadata of the power model, information from the node, all
Not
the
yet.
information that okay
Not
we
yet.
should-
We need that. Yeah.
Mhm.
Okay. Yeah, we need the metadata for the node as well. But currently I use only the performance values from the, yeah, you can see the performance values from the benchmark to create their to cluster server. So that is why I didn't add any metadata of the node. But of course we can add that as a requirement as well. Actually I hesitate a little bit because I'm not sure is the data that good for exposing or not. So we may have a discussion on that. Yeah.
Yeah, we can open to the community to discuss that.
Yes. And this is the example result for the JSON file of the query results from the Prometheus. Yeah, it will include the JSON file, and based on this one, we have a code to read it and to process it. So that is all. Okay.
So related to the data, so if I mean, if a repo just with data, so is some code license as Apache or some open data license?
To be honest, I
That's
have
a
no
free
idea about that.
discussion here.
Yeah, I think we really need that discussions, because to be honest, I don't have that much knowledge about the licensing of the open data. Yeah. Okay.
Kwame, and is there anyone in Red Hat that has this kind of knowledge that could help us?
Yeah, so just to share with you what we had on the CNCF application. So we had a question whether can we open source the model. So that becomes the issue. So the model is becoming as a code as important as the software code. So we said we also open source the model, but the data itself is there's some people who are willing to share the data, the raw data, but some people probably just want to keep it because due to privacy issues, they may not want to expose it. So I think we probably there's two ways we can work on it. One is we have the licensing, and the other way is we probably can do some of the post-processing before we submit the PR, make the PR submission. Post-processing will remove all those private, sensitive information, anonymize the information, or maybe we can select the model to be created without submitting the data. But that is definitely opened up a lot of discussions we are going to have, and I think that is one of the first projects I have ever seen in CNCF. That we allow people to open source model, open source the raw data. So we are definitely create the use case for CNCF.
Okay. Yeah, basically that is the first step, and the second step is on the training stuff, like what is the model, what is the training pipeline, how do we train the model? Do I have some? I'm sorry. I don't think so.
Yeah.
Okay.
Continue.
Yeah. Basically, there is two types of the power model that we are going to create. One is the thing we call absolute power. Another thing is we call the power dynamic power. So the difference between these two is that let's say the absolute power is the power that we measures, while the dynamic power is the power that we associated with the workload process or with the single containers. So this is the different levels of the power model that we are going to work on. Because we compute the dynamic power. The simple way is like the measure powers minus the power that we measure at the idling state. So the increased power is something that we call the dynamic, and it should associate with the workload that we just added to the system. And we also call it like isolated power, because we isolated some part out to get just only the dynamic part. Why we have to separate it? And what that is for. So let's say that we have the server, two kind of the server at the idling part, at the idling state. For one kind of the server, let's say server A is made like have a 20 watt, and the server B is have 30 watt. But after we add the workload, ideally we expected something to have similar dynamic power for the same workload. So in this case, you can see that we need three numbers for the labeling. So we need at least three model. One is for the node level here. Another one is for the node level here. And another one that we expected to be the same is for the workload or for the containers. So basically, this is how I separate between the absolute power and the dynamic powers. And this is a training pipeline. I'm not going to go into the detail, but for the one who want to contribute, so I will quickly talking about that. That in the training pipeline, we will have an input from the query that similar format that you've seen from the previous demo. We are going to extract that into the data frame. We implement it in Python. And then we do the isolation for the dynamic power. We remove the idling part or the background part. I will not go into detail of the isolations. It's already in here explaining in the model training slide pipeline. I'm not sure, it's not going to show. Anyway, yeah. The last one is to do the training, apply the learning method to create the model, upload that to the model database. That is what we expected, and this is how its structures happen. For the last part, after we train the model, we got like a bunch of the model for each type of the node. We have the deploy the model servers, API server that have an access to that one, and also the clustering stuff as well. This is some examples that we expect in the model request, like as Huaming and you have already discussed that in the futures, we may have like many kinds of the power source. Users like put the source input, like what how to say, the sort of the training coming in, and the output type, and the metrics that available over there. In some system that may have just only the C groups available. Some system we have just only the IRQ metric available. Some server we have the color available. So it's depend on that metrics. Yeah, it will be trained by a multiple group of the features to make it compatible one. And also the node type, the weight is something, I'm not sure that how many of you get used to it, but there is a two-way that we apply the model in the Kepler in the system that we don't have the power measurement. One is the linear regressions that we apply the weight directly by the model package inside the exporter. And we have another component called Kepler estimator. That one will allow us to apply any kind of the model, including the any like from the scikit XGBoost and those stuff. So we have two types of the model to apply. One need the estimator, another one don't need the estimators, but it will be a simple one by the linear regressions. And the other filters stuff and examples of the model response. If we want just only the weight, it will be simple JSONs that apply the linear regressions. If we not, and we use the estimators, it will return the zip file as a folders, and then it will like run the Python code to apply the model. Yeah, and this is the milestone that I have in my mind, and I would like to have discussions, but I don't think we have that much time. And also the help idea, anything that are possible. So I will just keep it here. I will put this one in the discussions in the Kepler model server project as well. If you're interested on any step or any idea, we can have a further discussion there as well. Yeah, that is all. Any?
Yeah. Yeah. Thank you for the presentation. I think it's a great pipeline. I'd love to help. Just one thing I was a bit concerned about was the clustering. Maybe it might be a good idea if we sort of kind of separate that from the general pipeline, just because depending on how much data a contributor can provide, if it's too little, we might just end up getting very like merged clusters or clusters that don't actually exist, or sort of like false clusters that can really hamper the model server. So maybe if we separate that and sort of pursue a unsupervised learning clustering strategy, I guess, maybe and have it sort of be a long-term process where we provide as much data as possible, we can then get more accurate clusters. So I was just wondering if that might be a better idea.
Yeah, because I'm not sure because like currently we are trying to separate the model for the separate type of the server, right? The as our Tama is already, I think it's Tama, right? Tama is already said that we may start with the CPU architectures, like different CPU architectures may go to the different type of the model. Another thing is very important is like the frequency, CPU frequencies. I can show you a simple examples that I do the clusterings. I run the same servers, but have a different setting of the CPU, maximum CPU frequency. I run is I collect the data for 6 data set, and each two of set to 3 max how to say, have a different 3 different CPU frequency setting. As you see, there are 1.3, 2.6, and 3.9, and run is 2 times. So I have a 6 data as an input, for examples. And I apply the k-means for do the clusterings from the performance. And you can see that we can at least properly group it correctly. So I expecting a bigger thing, like when we have a more complicated, not just only the CPU setting that difference, but also the CPU architectures and the orders, memories, and a lot of the different that we cannot figure out, like a specific conditions of the clustering. So I expect to have using the unsupervised model for clustering to the group. But this one will not be like that frequent. We can do it like a quarterly when we collect a lot of the data from the contributor. We make a single phase of the clustering. We can have a set of the model for each quarter or something like that. That is what I expected.
Yeah, I think that's that. Oh, sorry.
Yeah, sorry. So I just has a question with current current size there. May I know how many node have you tested and displayed this current figure? So I just wondering if this k means if I'm correct, the k means the k means cluster.
Yeah, K-means clustering.
Yeah, so currently we just have some seems 6 sample. So yeah, could you please run more samples? So somehow maybe because the CPU frequency is increasing and we get increasing from the 0.0 to the raise up there as a curve. So I just wondering if its k-means are some linear.
It's not about the linear or not linear, but it's mean like we have a resource of the performance values from this from the benchmark. Let's say when we have a new server, we can run the benchmark to test the CPU's performance, right? And we can test the memory and everything performance. And you can somehow group the performance values of the servers. And this one, you can see that if you like limit the highest frequency, CPU frequencies, it's also limit the performance. And that is is act differently on the power as well. So what we are trying to do is, okay. Are you saying something?
No, I have a question, but I will do after you finish.
Yeah, maybe I can finish it here.
Okay, so my question now is, I didn't understand that part before. So you are doing the clustering, like for example, in this case here, 3 different, configurations, different frequency. Are you creating a power model for each frequency, or the power model you're training for all the frequencies? I didn't get that.
It will train for each group. So it will turn out to like for the different frequency, but actually it is for that group. So it means it doesn't matter if you have another server that run with like 1.0 gigahertz, it will like group into the node type zeros, as will have the same model as is running from the 1.3.
Okay, so you are creating one model for each frequency range.
Yeah, it's good. Yeah, yes.
Like smartwatch. Ah, I see. It wasn't clear for me. Okay. Because in my model, I actually training with all the frequencies together. You know, I just create only one power model for node. But we can discuss that later. Just it's fine.
Yeah, it could work together. I mean, like I also have in the pipeline, it also support the categoricals or features as well. That can be like for the CPU architecture, it can be one part of the feature as well in the trainer. So yeah, it should support both. This one is more like general, like you can like separate the model, or you can mix all of the data together to create a universal model. Yeah, I think I'm not sure it's already run out of the time. So yeah, Huomin, you can get the stage back.
Thank you, Pan. I think this is a very interesting piece of work. So this is, I mean, there's a lot of questions, there's a lot of innovations, and lots of things we need to consider. So I think as the bare minimum, we should address the pipeline, the new training pipeline running, and then once we get more understanding about how we can profile the server and cluster them. What's the best, like I said, what's the best way to cluster the models? Then we probably can open up the discussion for the profiling and clustering, and then we can create yet another ways to make it happen. Thank you. So we have two more meetings in this agenda. No, in the coming 2 months before we cast the 0.5 release. So anybody want to have anything to discuss for the next 2 meetings, please just fill in the meeting agenda, and we're trying to accommodate as much as we can. Thanks so much, and have a great 2 weeks, and see you too on Slack.
Thank you.
Bye-bye.
Thank you.